Picture this. You're standing outside on a completely pitch-black night. You're looking up, actively trying to find the absolute darkest, emptiest patch of the sky you possibly can. You're searching for this microscopic pinprick of nothingness where absolutely zero stars are shining. Just a barren void. Now, imagine taking the most powerful, the most wildly expensive piece of scientific machinery humanity has ever built and pointing it directly into the heart of that total darkness. Welcome to this explainer, where today we're diving into one of the absolute greatest mysteries in modern astronomy. We're going to unpack an audacious, almost crazy scientific experiment that completely shattered our understanding of the cosmos. This is the story of the Hubble Deep Field. So you really have to ask yourself, why on earth would anyone point a billion-dollar telescope at absolutely nothing? Well, to understand that, we have to rewind to the mid-1990s. The Hubble Space Telescope was, without a doubt, humanity's crown jewel. It was up there orbiting Earth completely free from the blurring, mudding effects of our atmosphere, and it could see the universe with a level of clarity that was just previously impossible. Because of this, telescope time was precious. Unbelievably precious. Astronomers from all over the world were fiercely competing, submitting these grueling proposals to peer review boards just to get a few hours to look at known targets, like dying stars or nearby galaxies. But the director of the Space Telescope Science Institute at the time, Bob Williams, he made a radical choice. He decided to use his own personal allocation of observation hours, something called director's discretionary time. By using this special allowance, he completely bypassed that fierce peer review process. And honestly, they almost certainly would have rejected his proposal anyway, because it sounded absurd. He took a massive chunk of this incredibly valuable time to stare at a completely empty, pitch-black patch of sky right near the Big Dipper.
Section 1. The Ultimate Gamble. Betting on the dark. So, what were they actually hoping to find in the dark? This decision was highly controversial. It deeply confused and frankly angered a lot of scientists at the time. Critics were loudly arguing that it was an egregious waste of resources. They were absolutely convinced Hubble would stare into the dark and see exactly that, just dark. Staring at nothing for days on end, when there were so many known fascinating targets waiting to be studied, it seemed incredibly reckless. It was a massive bet, and if it failed, it was going to be a very public, very expensive embarrassment for NASA. But Bob Williams had this profound hunch. He was operating under a really fascinating premise. What if space wasn't truly empty? What if the light from the most distant objects in the universe was just so incredibly faint that our telescopes had simply never lingered long enough in one spot to capture it? They were literally looking for the edge of the known universe. Which begs the question, what happens when you risk everything to see if the dark is holding a secret?
Section 2. Staring into the abyss. The agonizing wait. The team on the ground had absolutely no idea what they were going to get. They were quite literally staring into the abyss. And you have to remember, this wasn't just a quick point-and-shoot snapshot. It was a grueling, continuous process of collecting individual photons, single particles of light, that had been traveling across the freezing vacuum of space for billions of years, just to finally hit Hubble's sensors. The observations spanned across 10 agonizing days in late 1995. On day 1, Hubble locked its gaze onto that pitch-black void. It took orbit after orbit around the Earth, keeping its mechanical eyes fixed on that single, tiny grain of sky. By day 5, the telescope was slowly, painstakingly gathering the faintest traces of ancient light, stacking exposure upon exposure to build a visible picture. Finally, by day 10, the continuous observation was completely finished. They had taken 342 separate, agonizingly long exposures of this one microscopic spot. The sheer weight of the anticipation in the control room must have been palpable. Would 10 days of staring into emptiness yield anything at all? Picture the scientists huddled closely around those early, boxy 90s computer monitors as the raw data slowly downloaded, line by agonizing line. Dead silence in the room as the unedited images began to compile on the glowing screens. They had risked reputations, time, and billions of dollars on this empty patch of sky. If the image resolving before their eyes was blank, it would confirm the skeptics' worst fears. It would go down in history as a colossal failure. But as the image finally finished processing, what they saw made their jaws hit the floor. Section 3. The shocking discovery. Light in the darkness. They were definitely not looking at a blank screen. They were looking at an absolute explosion of jewels set against the black velvet of space. It was a moment of pure, unadulterated awe. The ultimate gamble hadn't just paid off. A staggering masterpiece of cosmic architecture slowly revealed itself right in front of them.
Over 3,000 distinct glowing objects were crammed into this single pinpoint of sky, and we really need to keep the scale of this in mind. To put that into perspective, the patch of sky they observed was roughly the size of a single grain of sand held at arm's length against the night sky. In that microscopic sliver of supposedly empty dead space, Hubble had found a sprawling, crowded metropolis of light. And here's the craziest part. These glowing smudges, they weren't single stars within our own Milky Way. Nope. Almost every single speck of light in that image, the ancient spirals, the irregular blobs of early star formation, the systems colliding in these beautiful chaotic dances, they were entire, distant galaxies. Just think about the gravity of that for a second. Each one of those 3,000 glowing smudges contains millions, if not hundreds of billions of its own stars, its own solar systems, its own planets, all packed into a single grain of sand's worth of the night sky.
Actually, scratch that. Finding the galaxies was really just the first shock. Because as astronomers began to analyze the light coming from these distant cosmic islands, they realized something even more profound. They had inadvertently built a time machine. See, because the speed of light is finite, it travels at roughly 186,000 miles per second, it takes time for light to cross the vast distances of space. So when a galaxy is 10 billion light years away, it means that its light has been traveling through the dark void for 10 billion years before finally hitting the Hubble telescope. The light they were seeing wasn't just far away in space, it was far away in time. They were literally looking deep into the past, seeing these galaxies exactly as they existed in the universe's infancy, shortly after the Big Bang. Which opens up a huge question. How much do this actually change our understanding of everything?
Section 4, the expanding universe, rewriting the textbooks. This single revolutionary observation blew the lid right off our understanding of the universe's true incomprehensible size. Prior to this exact moment, estimates of the number of galaxies in the universe were, well, largely educated guesses that significantly underestimated the true density of the cosmos. Scientists were literally forced to march right back to their desks and rewrite the astronomy textbooks entirely. First off, the universe was revealed to be vastly larger and vastly more populated than humanity had ever dared to assume. Second, it provided hard proof that hundreds of billions of undiscovered galaxies are hiding in the dark, just waiting for a powerful enough eye to spot them. And third, modern astronomy was forever changed. It shifted the entire global focus to deep space cosmology, proving definitively that if we want to find the biggest answers about our origins, we have to look into the absolute darkest spaces.
But science, of course, never stops at a single discovery. The Hubble Deep Field was an absolute triumph, but it also became this tantalizing starting line. It sparked a burning, insatiable curiosity in the global astronomical community. Think about it. If Hubble saw this much cosmic architecture just by staring at a patch of sky invisible in ultraviolet light, what happens when we look even deeper? What happens when we push the very boundaries of our technological capabilities to see the galaxies that were simply too incredibly faint or too ancient for Hubble to capture?
Section 5, Hubble versus James Webb, the next generation of discovery. So, decades of engineering and billions of dollars later, humanity launched the next great eye in the sky. To truly understand the universe's origins, we needed a tool that could look past the limits of optical light, peering right through dense cosmic dust and time itself. While the Hubble Space Telescope primarily observes an optical and ultraviolet light, the new James Webb Space Telescope is heavily optimized for infrared light. And there is a very specific, totally fascinating reason for this. Because the universe is constantly expanding, the visible light from the very first galaxies has literally been stretched out over billions of years as it travels through space. This stretching actually shifts the light into the invisible infrared spectrum by the time it reaches Earth, a phenomenon scientists call cosmic redshift. James Webb was built specifically to catch that stretched, ancient light, allowing us to peer even further back in time than the original deep field ever could. Now, it is incredibly easy to get completely lost in the hard data here, right? The infrared wavelengths, the technological marvels, the sheer, staggering statistics of billions of galaxies. But beyond the hard science, beyond the staggering mathematics of the cosmos, lies a much deeper, far more personal question. It's a question that every single person who looks at the deep field image inevitably asks themselves. When you see thousands of entire galaxies floating in a grain of sand, the science suddenly becomes deeply, unavoidably existential. Section 6, Are We Alone? The ultimate question. And that brings us to the philosophical climax of our exploration today.
When you realize that our entire Milky Way galaxy is just one of an estimated 2 trillion galaxies in the observable universe, the sheer volume of cosmic real estate becomes just impossible to ignore. When you take those 3,000 galaxies found in a single microscopic patch of sky and you multiply that density by the entire 360-degree sphere of the night sky, the math becomes staggering. We arrive at trillions of galaxies, each bursting with billions of stars and potentially trillions of orbiting planets. We are forced to question what this means for the existence of humanity. Statistically speaking, the probability that our tiny blue rock is the only place in this unfathomably vast ocean where life sparked into existence seems almost absurdly small. The deep field doesn't just show us space, it shows us potential.
That single image of a tiny, dark patch of sky changed our entire perspective of our place in the cosmos forever. It proved that the dark is never truly empty, but rather brimming with ancient light and endless possibilities. So we leave you with this final thought based on what we've seen today. How many civilizations do you think exist in the universe? Tell us in the comments. And subscribe to Curious Orbit for more space mysteries and science documentaries.